Hi, today we are going to discuss the concept of semaphore. Let us discuss what is semaphore. Basically, semaphore is a synchronization primitive, so which is going to have a logs. For example, if you are having a higher level than a logs, so it is going to be implemented. It is invented by Distra in 1968 as a part of the OS. Semaphore is a variable that is manipulated atomically through two operations called signal and wait. For example, wait. So it is a decrement block until semaphore is open. It is also called the operation P. After a Dutch word for the test, it is also known as down. Signal. It is a called it is called increment. It allows another to enter. It is called V. So it is called increment. It is also called as up. Semaphore are system implemented data structures that are shared between processes. Features of semaphores. Semaphores are used to synchronize operations when process access a common, limited, and possibility non-shareable resource. Each time a process wants to obtain the resource, the associated semaphore is tested. A positive non-zero semaphore value indicates the resource is available. Semaphore system call will be invoked by default, so the cause of invoking process to block if the semaphore value indicates the resource is not available. Uses of semaphores. So basically it is used to solve the critical section problem. So here the value will be initially 1 semaphore that control the access to a single resource taking the value of 0. The resource, it means resource is in use. So R1, the resource is available. So these are often called binary semaphores. The precedence enforcer, initial value is 0, semaphore ensuring an ordering of execution among concurrent processes. Resource counter, initial value is n. Semaphore controlling access to n multiple resources, thus assuming a range of non-negative values, are frequently called counting semaphores. There are two types of semaphores. So one is binary semaphore and another one is counting semaphore. So binary semaphore is called aka mutex semaphore. So which is implemented in Linux. Because of that reason, aka was preceded before mutex semaphore. It guarantees mutually exclusive access to resource. Only one thread or process is allowed entry at a time. The counter is initialized to 1, so which will be having 0 or 1. Counting semaphore. It represents a resources with many units available, allows threads or process to enter as long as more units are available. Counter is initiated to n and n equal to the number of units are available. So its range is minus infinity to plus infinity. Critical section problem. So let us consider what is critical section problem. So this is a common code among multiple process keeps it. Allows process to enter into the critical section. It executes its task and exit. So here we are having a two types of. So here P stands for down or wait. So whatever whenever P operation is incremented, it will be decremented. It goes to the wait state. So whenever V operation is invoked, it will be invoked and it goes to the up state, it will be incremented. This is called signal or release state. Let us consider the code. So here we are performing the two operations, P operation and V operation. So here if you are going to consider the P operation, so what we are doing? So semaphore will be entering into the critical section. So it will be we are going to perform the down operation. It means we are going to decrement the semaphore. For example, a value will be sent to the semaphore S. So now what is going to happen? So S value will be decremented by 1. So whenever, for example, semaphore value is 3, so value of semaphore will be decremented by 1, it will becomes 2. So here if the particular value is less than 0, it means you have entered a value which will be a minus 1, so it is less than 0, so then it will be putting the process in the process control block. It means it will be going to the sleep state or wait state. So otherwise it is going to return the semaphore. Next, V operation. In V operation, it is going to increment the semaphore by value of 1. So whereas in P operation, we are going to decrement the value of semaphore by 1. So here also we are going to check the value. If the value is less than or equal to 0, so then we are going to wake up the process. So it should be less than 0 or equal to 0, then we are going to wake up the process. Otherwise it will be incrementing the semaphore. So let us consider with an example. So now here we are having a 3 process P1, P2, P3. It enters into the critical section. Let us consider the semaphore value is 3. So now what is going to happen? So now here if you are going to consider the P operation, so P operation is going to decrement the value of semaphore by 1. So now what is going to return the value? It is going to return the value 2. P2 is going to enter. So now the P2 will be 2. So now the P2 value will be decremented by 1 and it is going to return the 1. So next P3 will be entering. So P3 is going to be entered and let us check what is the P3. So now P3 value is 1 minus 1, so which is 0. So now here we are going to check the condition. So 0 is less than 0. So it means 0 is less than 0, the condition is failed. So what happens if P4 is going to enter? So for example, P4 you are going to enter into the semaphore. So only 3 number of process will be having. So either 0 or 1. So let us check the what happens P4 enters into the semaphore. So already its value is 0. Already its value is 0. So now the value becomes 0 minus 1. So which will be minus 1. So it will be a negative value. So here all the 3 process enter into the critical section. So now in a similar manner, if P1 has completed the operation, it need to wake up. So now P1 has decremented here. So now P1 has a completed operation. What it has to do? It has to increment the value of 1. So because we need to up the operation, so that it has completed, the next value comes into the critical section. So for example, P3 has entered, so 1 minus 1, so it is going to return. So it is 0, 0 less than 0, so it doesn't enter into the particular this one, so it will be returning. So it will be checking, so 0 is less than 0, so which will be true. So now 0 will be wake up. It means up to P3 it can able to enter the critical section. So after P3 whatever the values are entering, so it will remain in the block state. So next P4 will be kept into the PCB. So put P4, so minus 1 is less than 0. So minus 1 is less than 0, which is true. So now put the process in process control block, suspended list, sleep. So it goes to the suspended list and it goes to the sleep state. So now we are going to put the P4 in the PCB, which is blocked state. So next, for example, P5 enters. So if P5 is going to enter, so here P5 value will be minus 1, it becomes minus 2. So minus 2 is less than 0, which is also true. So what we are doing, put P5 in the PCB wait state, so which is blocked. So P5 will be also in the blocked state. Similarly, whatever the values we are going to enter, so it remains in the block state. More than 3 process, because its value is 3, so you can able to enter more, but if you are coming down, so it will be entering into the PCB only, it goes to the block state. So let us consider the scenario if S equal to 0, the process remains in the suspended list. If S equal to 10 means all 10 can enter into the critical section. If S equal to -1, it means it is unsuccessful, it remains in the block state or a region. Next one is binary semaphore. So let us consider binary semaphore. It is having a values either 0 or 1. Already we know the scenario. P means decrement and V means increment. It is going to give a signal. So now here if you are going to consider the semaphore down, so here the value is equal to 1. If value is equal to 1, so make it to 0. So make S value to 0. So else block the process and place into the suspended list and it goes to the sleep state. Similarly, up semaphore, so it is going to check if suspended list is 0 or empty. So then make the value as 1. So check whether it is suspended list is either 0 or empty. So then make the value as 1. So otherwise it is going to wake up the process. So here if you are going to consider an example S equal to 1, so make it to 0. So if higher one comes, make to the block state. For example, S equal to 2 or 3, so either 0 or 1. So S equal to 1, make it to 0. If you want to up the semaphore, make 0 to 1. So if higher values comes, so it will be remains in the block state. So consider an example, S equal to 0, make it to the 1. If process execution is completed, it will be wake up. So here we are having a gate question on semaphore. Semaphore operations are atomic because they will be implemented within kernel operating system. The next question, at a particular point of time, the semaphore value is 7. Then 20p operations and 15v operations are completed on semaphore. The resulting value of semaphore is we need to find out. For example, we have seen, so p means decrement and v means increment. So next what we are doing, so here we need to find out the value of the semaphore. Already the value of semaphore is 7. So next here what values we are performing, so we are going to perform 20p operations and 50v operations. P means decrement, so 20 times we are going to decrement, 15 times we are going to increment the value of semaphore. So decrement means minus 20 and plus 15, so which will be resulting minus 5. So already the total number of semaphore is 7. 7 minus 5, which is resulting 2. So this is the answer. So next, counting semaphore. So it was initiated to 10 and then 16p and 14v operations were performed on semaphore. The resulting value of semaphore is. So here p means increment, v means decrement. So what is p? So p is 6 and v is 4. So next, so 6 minus 6 plus 4. So which will be resulting minus 2, and here so total number of semaphore is 10, so 10 minus 2 which will be resulting 8, which is the answer. So next one, so consider a non-negative counting semaphores. The operation of p of s decrements s and v of s increments s. During the execution 20p operations and 15v operations are issued on same order, the largest value of which at least one operations will be remain blocked. So let us consider, so here given non-negative semaphore, so at least one p operation will be blocked. So it means among the 20 operations, one operation is blocked. So here let us see what is going to happen. So p means increment and v is decrement as usual. So at least one operation should be remain blocked. It means 20 minus 1, so which will be remaining 19. So now, so how many v operations are 12, so minus 19 plus 12 which will be resulting minus 7, which is the answer. If you like this video, please like, share and subscribe my channel. Thanks for watching.